Science, Class 9th, Chapter 3, Part 2, Table 3.1, Symbols of some elements. Element symbol: Aluminium Al, Argon Ar, Barium Ba, Boron B, Bromine Br, Calcium Ca, Carbon C, Chlorine Cl, Cobalt Co, copper Cu, fluorine F, gold Au, hydrogen H, iodine I, iron Fe, lead Pb, magnesium Mg, neon Ne, nitrogen N, oxygen O, potassium K, silicon Si, silver Ag, sodium Na, sulfur S, uranium U, zinc Zn. The above table is given for you to refer to whenever you study about elements. Do not bother to memorize all in one go. With the passage of time and repeated uses, you will automatically be able to reproduce the symbols. 3.2.2 Atomic Mass. The most remarkable concept that Dalton's atomic theory proposed was that of the atomic mass. According to him, each element had a characteristic atomic mass. The theory could explain the law of constant proportions so well that scientists were prompted to measure the atomic mass of an atom. Since determining the mass of an individual atom was a relatively difficult task, relative atomic masses were determined using the laws of chemical combination and the compounds formed. Let us take the example of a compound carbon monoxide formed by carbon and oxygen. It was observed experimentally that 3 gram of carbon combines with 4 gram of oxygen to form carbon monoxide. In other words, carbon combines with 4 by 3 times its mass of oxygen. Suppose we define the atomic mass unit, earlier abbreviated as AMU, but according to the latest IUPAC recommendations, it is now written as U, unified mass, as equal to the mass of one carbon atom. Then we would assign carbon an atomic mass of 1U and oxygen an atomic mass of 1.33U. However, it is more convenient to have these numbers as whole numbers or as near to whole numbers as possible. While searching for various atomic mass units, scientists initially took 1 by 16 of the mass of an atom of naturally occurring oxygen as a unit. This was considered relevant due to two reasons. First, oxygen reacted with a large number of elements and formed compounds. Second, this atomic mass unit gave masses of most of the elements as whole numbers. However, in 1961, for a universally accepted atomic mass unit, carbon-12 isotope was chosen as the standard reference for measuring atomic masses. One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon-12. The relative atomic masses of all elements have been found with respect to an atom of carbon-12. Imagine a fruit seller selling fruits without any standard way. With him, he takes a watermelon and says, "This has a mass equal to 12 units, 12 watermelon units, or 12 fruit mass units." He makes 12 equal pieces of the watermelon and finds the mass of each fruit he is selling relative to the mass of one piece of the watermelon. Now he sells his fruits by relative fruit mass unit FMU as in figure 3.4. Similarly, the relative atomic mass of the atom of an element is defined as the average mass of the atom as compared to 1/12 the mass of one carbon 12 carbon 12 atom. Table 3.2 atomic masses of few elements. Element atomic mass in unified mass. Hydrogen 1, carbon 12, nitrogen 14U, oxygen 16U, sodium 23U, magnesium 24U, sulfur 32U, chlorine 5.5U, calcium 40. How do atoms exist? Atoms of most elements are not able to exist independently. Atoms form molecules and ions. These molecules or ions aggregate in a large numbers to form the matter that we can see, feel or touch. 3.3 What is a molecule? A molecule is in general a group of two or more atoms that are chemically bonded together, that is tightly held together by attractive forces. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Atoms of the same element or of different elements can join together to form molecules. 3.3.1 Molecules of elements. The molecules of an element are constituted by the same type of atoms. Molecules of many elements such as argon, helium, etc. are made up of only one atom of that element, but this is not the case with most of non-metals. For example, a molecule of oxygen consists of two atoms of oxygen and hence it is known as a diatomic molecule O2. If three atoms of oxygen unite into a molecule instead of the usual two, we get ozone O3. The number of atoms constituting a molecule is known as atomicity. Metals and metals and some other elements such as carbon do not have a simple structure but consist of a very large and indefinite number of atoms bonded together. Let us look the atomicity of some non-metals. Table 3.3 Atomicity of sub elements. Type of element non-metal. Name atomicity. Argon monoatomic, helium monoatomic, oxygen diatomic, hydrogen diatomic, nitrogen diatomic, chlorine diatomic, phosphorus tetraatomic, sulfur polyatomic. 3.3.2 Molecules of compounds. Atoms of different elements join together in definite proportions to form molecules of compounds. Few examples are given in table 3.4. Table 3.4 Molecules of some compounds. Compound combining elements, ratio by mass. Water H2O, hydrogen oxygen 1 is to 8, ammonia NH3, nitrogen hydrogen 14 is to 3, carbon dioxide CO2, carbon oxygen 3 is to 8. Activity 3.2. First, refer to table 3.4 for ratio by mass of atoms present in molecules and table 3.2 for atomic masses of elements. Find the ratio by number of the atoms of elements in the molecules of compounds given in table 3.4. The ratio by number of atoms for a water molecule can be found as follows. Element ratio by mass, atomic mass ratio by atomic mass, simplest ratio. H ratio by mass 1, atomic mass 1, 1 by 1 equal 1, oxygen 8, atomic mass 16, 8 by 16 equal 1 by 2, simplest ratio 2 is to 1. Thus the ratio by number of atoms for water is H is to O to equals 2 is to 1. What is an ion? Compounds composed of metals and non-metals contain charged species. The charged species are known as ions. Ions may consist of a single charged atom or a group of atoms that have a net charge on them. An ion can be negatively or positively charged. A negatively charged ion is called an anion, and the positively charged ion a cation. Take for example sodium chloride NaCl. Its constituent particles are positively charged sodium ions and negatively charged chloride ion. A group of atoms carrying a charge is known as polyatomic ion. Table 3.6. We see more about the formation of ions in chapter 4. Table 3.5. Some ionic compounds. Ionic compound constituting elements ratio by mass. Calcium oxide, calcium and oxygen 5:2. Magnesium sulfide, magnesium and sulfur 3:4. Sodium chloride, sodium and chlorine 23:35.5. Thank you for this time. Have a nice day. Take care.